Here is a checkerboard, 9 squares by 9. How many black squares are on it? Go on, start counting them one at a time and see how far you get before it goes wrong. Somewhere around 30, you lose your place. You are not sure you didn't skip one, and not sure you didn't count one square twice. There is a way to know the answer for certain, without ever counting a single square twice. Once you learn to read the pattern, you can count squares, tiles, bricks, and even the hidden red faces on a pile of painted cubes, without ever going one by one. The shape itself will do the counting for you. Start smaller with an 8 by 8 board. Instead of the whole thing, look at just one row. 4 black squares and 4 white squares, 8 across. And there are 8 of those rows stacked going down. So the whole board is 8 times 8, which is 64 squares. And because 8 is an even number, every row splits evenly. So black and white come out exactly equal, 32 of each. No counting, just rows times columns. Now stretch it to 9 by 9, 9 squares in a row, 9 rows, so 9 times 9, 81 squares in all. But here is the catch. Do the two colors still split evenly like before? Watch the corners carefully. The board starts on white and it ends on white, so all 4 corners are white. That tips the balance by exactly 1 square. There is 1 more white than black, so 81 splits into 41 white and 40 black. You can check it the slow way if you want. The white counts along the 9 rows go 5, 4, 5, 4, and so on, and they add up to 41. The blacks add up to 40. Same answer, far more work. The odd side of the board is what tipped it. Here is a wall with a snowflake-shaped hole in it, and your job is to patch the hole with 6-sided tiles. How many tiles do you need? The jagged edge makes you want to count corner by corner. Please don't. Look instead at how honeycomb fits together. 1 tile sits right in the middle, and 6 more tuck around it, 1 against each of its 6 sides, 1 in the center plus 6 in the ring, so 7 tiles fill that snowflake exactly. A brick wall has a broken patch, and you need to know how many bricks it takes to fill it. The gap looks ragged, and counting loose bricks in a pile is easy to get wrong, so rebuild it the way a wall is actually built, 1 course at a time. From the bottom up, the courses need 1 brick, then 2, then 2, then 1, then 2, then 2. Add those courses together, 1 plus 2 plus 2 plus 1 plus 2 plus 2, and the patch takes 10 bricks. The rows kept your count honest. Now for something you genuinely cannot see all of. Glue a stack of little cubes into 1 solid block, paint the entire outside red, and then pull all the little cubes apart again. The question is, how many red faces does each little cube end up with? Here is the real trap. Wherever 2 cubes were touching, that face got no paint, and while the block is still whole, those faces are tucked away inside, out of sight. Some cubes are buried so deep you never see them at all. Counting the red faces by eye is hopeless, so don't try. You do not need to see the hidden faces at all. Every little cube starts with 6 faces. The red ones are just 6, minus however many faces were touching a neighbor. So a cube's position in the block tells you its whole count. A cube on a corner touches 3 neighbors, so 3 of its faces are red. Along an edge it touches 4, so 2 are red. In the middle of a face it touches 5, so 1 is red. And buried right inside it touches 6, so none of it is red. Try a genuinely awkward shape, 8 cubes glued into the letter T, painted all over, then pulled apart. There are no neat corners and edges to lean on here, so read each cube's neighbors instead. The 2 tips at the ends of the bar touch just 1 cube, so 5 faces red. The 2 cubes next to the join each touch 2 neighbors, 4 red. The join in the middle touches 3, so 3 red. Then down the stem, 2 cubes touch 2 neighbors, 4 red, and the very tip touches 1, 5 red. That is 3 cubes with 5, 4 with 4, and 1 with 3, which is all 8. Now take a box cut into 18 little cubes, 2 layers of 3 by 3, with the whole surface painted. Don't go hunting for red faces one at a time. Just sort the cubes by where they sit, and the count falls straight out. There are 8 corner cubes, 3 red faces each. 8 cubes along the edges, 2 red faces each, and 2 sitting in the center of a face, 1 red face each. 8 plus 8 plus 2 makes 18. Every cube accounted for, and not one face counted by hand. One more kind. Here is a small grid. 4 upright lines crossed by 3 horizontal lines. How many rectangles are hiding inside it, counting every possible size? Try to spot them one by one, and you will almost certainly miss a few. So read the structure instead. Every rectangle is pinned down by 2 of the upright lines, which fix its left and right sides, and 2 of the horizontal lines, which fix its top and bottom. Pick a pair of uprights, pick a pair of crossbars, and you have framed exactly 1 rectangle. From 4 upright lines, there are 6 different pairs you can choose. From 3 horizontal lines, there are 3 pairs. 6 pairs of sides times 3 pairs of ends gives 18 rectangles in total, and you never had to draw a single one of them. Now step back and look at everything we just did. A board, a snowflake of tiles, a broken wall, piles of painted cubes, a nest of rectangles. Every single time, we stopped counting things one by one and started reading the shape instead. Rows times columns for the board, a center and a ring for the tiles, courses for the wall, 6 minus the neighbors for the cubes, pairs of lines for the rectangles. The structure was holding the answer the whole time, and a structure never loses its place. Your turn now. Take a bigger cube, 3 by 3 by 3, which is 27 little cubes, painted all over and then split apart. How many of them show exactly 3 red faces? Pause here and think about position, not about faces. 3 red faces means a corner, and every cube has 8 corners, so the answer is 8 every single time. And here is a bonus one. A single little cube sits dead in the center, touching 6 neighbors, so it carries no paint at all. You read the shape, you never counted a face. You can even place all 27, 8 corners with 3 faces, 12 along the edges with 2, 6 in the middle of the faces with 1, and that one hidden center with none, 8, 12, 6 and 1, and that adds to 27 exactly. Quick follow-up on that same big cube. Forget the little cubes for a second. How many little red squares are painted across the big cube's whole surface? Don't add up the cubes to find out. Pause and picture the surface. A cube has 6 faces, and each face here is a 3 by 3 grid, so 9 little squares. 6 faces times 9 squares each gives 54 red squares. Reading the surface beats adding up 27 separate cubes one at a time. Last one, a 10 by 10 board, 100 squares. How many are black and how many are white? Don't count them at all. Just ask whether 10 is odd or even, and remember what the 9 by 9 did. Pause. 10 is even, so each row splits 5 and 5, and the opposite corners land on different colors. This time, nothing tips the balance. The colors come out equal, 50 black and 50 white. The odd board leaned to one side, the even board stays perfectly level. This way of counting shows up everywhere once you notice it. Seats in a theater, rows times columns, windows on a tower block, boxes stacked on a pallet, even the pixels lit up on your screen. Whenever things sit in a regular pattern, the pattern is already holding the count for you. So before you ever start counting things one by one, stop and look at the structure first. The rows and columns, a symmetry, a corner or an edge, or a pair of lines. Let the shape do the counting for you, and unlike your finger, it will never lose its place. That's all for this video.